shall we resume it or?
Yeah.
Yeah, Shubham.
Yeah, we can resume it, Shubham. If you want break, then we are okay.
No, it's okay for me. It's quite easy because I'm doing this for years.
Okay.
So
Yeah,
okay, so let's start with VPC creation.
sure.
Okay.
Yeah.
So the first thing we should be doing is, uh, okay, let's create your user accounts first. So I am already inside AWS Management Console.
Are you sharing your screen, Shubham? Because we are not able to see.
Oh, it's not visible. Okay, let me stop it and
Uh,
reshare it.
I can
It
see.
was visible.
Yeah, it was
Oh, is
visible.
it?
Yeah.
How about now?
Yes, yes, it's visible. You are on
One
It's
sec.
AWS
visible.
page.
Uh,
Launch visit.
Yeah, visible, Shubham.
Visible,
uh,
right?
only I am not able to see it. I don't know
Maybe you
why.
can call connect again.
Yeah, maybe try doing that.
Yeah, let me just try connecting again.
So, Shubham, yesterday Rajesh provided one link and it has this account ID, right? So,
Yeah, correct. Yes. So we'll create an alias for this account ID so that we don't have to remember it.
okay.
Yeah, Shubham. Uh,
Is it visible now, Niyati?
yeah, now it is visible. Yeah.
Okay. So let me sign out. Can somebody please ping me the URL which Rajesh has pinged?
Yeah.
I just pasted it in the chat.
Okay, good. Thanks. See, normally we would simply go to this aws.amazon.com and then what we'll do is my account AWS Management Console, and then we have this option to log in as root user or as an IAM user. We'll discuss
Yeah.
about what root user is. Basically, root user is the email address with which you have created the AWS account.
Account.
So yeah, so typically you should never use this root user, and you should always use an IAM user to log in and administer. So for now, we'll do the same. So we'll use an IAM user to log into AWS Management Console, and for doing that, first thing we should know is the account ID or the account alias. So I think so. You saw that it's there, the 12-digit number. We can put it here and do next. As we don't know yet, so we'll use the link provided by Rajesh. So here we can see this is the account ID, and then this is my username, and this is my password, and I'll sign in. Ah, what happened? An error occurred. Please try again. Okay. Okay, I'm in. So let's create your user IDs. I'll go to IAM. IAM is nothing but identity and access management. So I'll go here. We'll cover IAM in detail later on, but for now I am simply creating a user accounts for all of you. So we'll go to users, and it is as simple as that. We'll go to IAM and then users will create will uh, so so let's do one thing. We'll create a group first. So user group, create group. We can
September
say
2021.
yeah,
AWS
okay.
September 20.
So AWS
ACPT
batch September
2021.
21. Okay. So I'm creating a group now, and create group. That's it. So a group has been created. As of now, no users belong to this group, and there are no permissions uh, that we have assigned to this group. So what we'll do
Okay.
is we'll go to this group and we'll assign some permissions here. Okay. So we'll go to permissions. We'll say add permissions, attach policy, and there is a policy called as power user. So this is power user access. So this basically, if you want to know what it is, uh, here is the description. It says provides full access to AWS services except for IAM. So you can do pretty much whatever you would like to do, but you can't, create users or give additional rights to any user. So as of now, I've created a group and I'm attaching this policy, power user access, add policies. So policies have been attached to this group.
This policy is already present by default, or you had created this policy?
It's already available in AWS pretty much for pretty much for every job function they have created policies and roles.
Okay.
And it's like, if you have a very specific requirement, then you may have to create specific very custom policies and custom rules. So but as of now, I mean, there are plenty of them which AWS has already created and we can use them. I mean, it suits most of the needs.
Hmm. Okay.
And so group has been created, permissions have been defined. So we have attached policy, what, power user access, which basically grants pretty much every access except for IAM. And now
So for
we'll create.
IAM, Shubham, if someone requires an IAM role too, like someone is belonging to the security team, okay. So
Okay,
what the policy is defined for that? Which policy for IAM?
IAM, okay, it's quite simple actually. If you go here and search for, okay, let me go here, add permissions, attach policy. There is, I think, administrator access.
Okay, okay.
uh,
Okay,
yeah. So basically this administrator access provides full access to
okay,
AWS services. So we can give administrator access. It includes pretty much everything.
okay. Got it.
That essentially makes us as a root user for the entire.
Yeah, you can say that,
Right.
but I mean, root user would have additional access with regards to, billing management
Oh,
and adding
okay.
or removing payment methods like that.
Mm-hmm. Right, got it.
So, okay, let's create users here. Now we'll add users, and the first one, let's create Niyati. And so what kind of access type we want to give to Niyati? As of now, we'll talk about programmatic access later on, and we'll see what access key ID and secret access key are. So as of now, we are not enabling programmatic access. This is basically for when you want to interact with AWS in a programmatic manner. Could be using AWS SDKs if you have written some piece of code and you are leveraging AWS software development kits. In that case, if you want to interact with AWS programmatically, you would require this access key ID and secret access key. So one way of interacting in a programmatic fashion is using AWS SDKs or AWS command line tools. Even in AWS command line tools, you can download and install on your local PC as well. If you would like to use AWS CLI to administer and do whatever interaction you would like, in that case, you would require programmatic access. But if you need just AWS management console, then we simply check this box that we need AWS management console access. We'll say next permissions, add
So
user
it
to
is
group.
something like Yeah, something like the public key which we add in the authorized keys for the next. Like suppose we want a passwordless SSH between two servers, we add the public key in the authorized keys of another server. Is it something like that? The concept of that programmatic m- management.
Um, yeah, in a way you can say that. Um, I mean, in SSH also you have something called as key pair, right? So you have a public
Right,
key and a private key. So
right,
uh, you can have a key-based passwordless authentication, and this actually these this secret access key and access key ID. This is also access key ID is similar to username, and secret access key is similar to password. And these two things you would require to you would have to somewhere in your code you have to put these two things, and then you're basically using these two things, basically your access key ID and secret access key. Your AWS SDK is basically signs the API calls. So
right,
it is basically for signing the API calls, and when basically an API call is made and basically the AWS service receives it, it basically checks it whether it is signed by the right access key ID and secret access key. I will see to that later on, but it's bit different you can say, but uh, yeah, in a way you can say that I mean normally we require a see
right,
typically where a human interaction is required, there would be username and password. But wherever some machine is working on our behalf, some code is working, so that also requires some kind of credentials to 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 basically authenticate itself, and even AWS needs a way to authenticate whether the requested call is allowed or not.
right.
So as of
Yeah, Shubham,
now
I think
we
something like yeah, sorry. I think something like we have CyberArk in our organization, like it uses API calls, and probably all the passwords are stored into that vault, and it the API recalls the password, and probably it triggers the backup.
Yeah, you can say that. Actually, API is sometimes it's hard for us people who are not from development background. So we sometimes
Mm-hmm.
it's hard for us to understand what exactly an API is,
Sure,
and
sure.
what does it mean when we are saying we are making an API call. What is an API endpoint, and what is an API client is what RESTful APIs are. But we'll get to that. We'll be creating some APIs also, RESTful APIs. So I think it will become more clear. So these APIs relies on basically HTTP protocol, and we'll see to that. But for
Correct.
now,
Yeah,
let's skip it because it will go
sure,
to some other direction.
Sure.
sure, Shubham. Yeah, thank you.
Okay. So um, okay, what password? Console password type auto generated. That should not be the case. Okay, fine. Oh, it's not created, right? Okay, forget about it. Let's simply create it here. I think there's a way of putting custom password also. So Niyati, I want to enable management console access. Next permissions. Uh, let's attach policies directly. No need to add it into a group. So for now, I will attach the same policy, power user access, and I'll say tags. If I want to, add some tags like, say for example, Niyati belongs to which team, so I can see a team. We can have some team, the team name, anything like that. So any key value pairs we want to associate with this user, we can specify it here. Next review. Console password type auto generated. Okay, fine. Let's go ahead with this only. Create user. Okay, download CSV file. Okay, so good. So this is the username, this is the password, and this is the console login link. Similarly, let's quickly create the other user accounts as well. Same users, add user. Rahim, you want to enable management console access?
We
Ah,
can add
here
another user as well, right?
at the same time. Ah, okay, good. Actually, Kaushik and
Salman.
Salman. Okay, good. So for all of them, okay, AWS Management Console. I think we have the option to put a custom password. So I'll put change me. Ah, shit. Okay, so
Change
change
me.
me, change me 123. Okay, and user must create a new password at next sign in. Okay, I think this is fine. Next permissions. So we'll attach the policy directly to the users, and we'll search for power user. We can also give administrator access, of course, but uh, so this policy I'm attaching. Next tags, review, create users, and we are done. Okay, the users have been created. Sit. Ah, okay. So the link you already have, and
Right.
for Niyati, this is the password, and for all of you guys, I think it is what change me
Change me
123.
1 to 3.
Right? Okay. So whenever you have some free time, try checking your access, whether you are able to log in or not.
Sure.
Okay, so let's now go and we'll try creating a VPC ourselves. So the first thing we should be doing is we should be selecting the AWS region which is closest to us. Okay, or closest
Right.
to the customer for which we are working. So maybe say for example, if a customer is US based, but we are supporting from India, of course, typically we would be creating resources in the US region only. So as of now, but we'll be creating in Asia Pacific Mumbai because we are all sitting in Mumbai and we'll get a much better latency from if we deploy resources in Mumbai. So I've selected the region here, Asia Pacific Mumbai, and then I can search in this search bar VPC. So VPC is
Right.
basically isolated cloud resources.
Cloud
So
resource.
whatever resources will deploy into VPC, that typically is isolated until you do some extra configuration. So here, once we navigate to VPC, we'll go to your VPCs, and by default, in every region, there will be a default VPC which is created for us, and we can start deploying resources into this VPC. But since we want to learn it ourselves that how to create VPC, we'll not use the default VPC, but we will create our own VPC. So I'll click on create VPC. I'll give this VPC a name. So let's say this is what this is a VPC where our QA resources are deployed. So let's say QA VPC. Then we have to put a IPv4 CIDR block. It's nothing but the network address. So let's use the same one which for which we have created a sub. I mean, which for which we have created subnets. So let's copy this and we'll put it here. And for now, we'll say no IPv6 CIDR block. So we are not going to use IPv6 with this VPC as of now. Later on, we'll see how to deal with IPv6. So that's it. And we'll create a VPC. Now,
So Shubham, cider, what is the full form of cider and
CIDR is basically classless interdomain routing. Uh,
okay,
it's not a very important concept. So, I mean, let's not get into that. So,
sure.
the main thing that we should be understanding is that how to interpret this, that what slash 24 means. Because just now, when we have created this VPC, we have put a network address there, and we have also put slash 24. So we should know what slash 24 means, what subnet
Mm,
mask means, right?
right,
So
right.
that's more than enough.
How about
And
tenancy?
tenancy also we'll discuss what tenancy means. Tenancy also is like shared and dedicated. We'll come to that later on. For now, let's create VPC. So we have created a VPC. We'll try to create something similar what we have here. So here in this VPC we have four subnets. Two of them are public and two of them are private. So let's try to do that. VPC has been created. We have not yet created subnets. So now we'll create subnets. We'll go to subnet section here and we'll say create subnet. And then under which VPC we want to create a subnet, we'll select our VPC, which is QA VPC. Okay. Now here we can give subnet name. We'll say this is uh, QA VPC public subnet 1. So this is the subnet name. Then availability zone, let's say uh, AP South 1A. So we are creating our first subnet in availability zone 1A. And then what is the subnet address? Let's use the first one, dash 26. Create subnet. Okay, similarly, we'll create three more. Create subnet, in which VPC we are creating this subnet. It is QA VPC. What is the subnet name? Let's say uh, QA VPC public subnet 2. So just like in this architecture, we see these subnets are in different availability zones. So first public subnet is in AZ1. The second public subnet is in AZ2. So the same thing we'll do here. Uh, Here we'll select the AP South 1B and we'll put the subnet address here. The second one. We'll copy this and we'll put it here, and then we'll say slash 26 and create subnet. Now similarly we'll create two more. These are going to be private subnets. So it is QA VPC private subnet 1. So private subnet 1, this is also in 1A, and we'll use this one slash 26 create subnet,
So, Shubham,
and then
uh,
yeah.
AWS doesn't charge for these kind of activities, right? Creating.
Yeah, it doesn't charge you anything for creating VPCs, subnets, route tables, or internet gateway. I'll let you know if any resources are chargeable. So I'll explicitly let you know that these are chargeable and you should be careful. But anyways, in free tier, a lot of services are free for us to explore, but some services are not part of free tier. So I'll explicitly let you know that if at all we are going to do an exercise, I'll let you know that these are not part of free tier. And if we are going to charge, we are going to get charged if we do it. Of course, we can do this in training account, but as soon as we are done, we should be terminating these resources because otherwise there'll be a huge bill at the end.
Thank
Okay, so let's create the last one, this QA VPC, and this is what QA VPC private subnet 2. and I'll put this in 1B again, and then this is the last one /26. So as of now, we see that, okay, let's try to minimize this. And okay, so we have created 4 subnets inside our custom VPC. 2 of them we are calling them as of now public, and 2 of them we are calling it as private. But as of now, there is nothing which makes them different from one another, because as of now it's just same. It's just that we have named it like that, that these are 2 public subnets and these are 2 private subnet. But as of now, it's just the label which is saying that, but there's I mean, as of now there's no difference. So let's see what actually makes a difference and what exactly makes a subnet public. So now once we are done with with VPC creation, and once we have created the required subnets in that VPC, we have to decide whether we want to give internet connectivity to some of the subnets or not. So in case, say for example, if there is some internet accessible web application that we want to deploy onto this VPC, then we would require internet connectivity. And how do we give internet connectivity? By creating an internet gateway and attaching to this VPC. Okay. So what we'll do is we'll go to internet gateways. We'll create an internet gateway. We'll say this is QA VPC IGW. So this is an internet gateway for QA VPC. I'll simply say create internet gateway, and then I'll attach this internet gateway to QA VPC. Under actions, we have this option to attach it to a VPC, and then I'll select the VPC that we just created and we'll say attach internet gateway. So far what we have done is we have created a VPC, we have created 4 subnets inside that VPC, and we have created an internet gateway, and we have attached the internet gateway to this VPC that we just created. So far we have done this. So now just one last piece is remaining, which is route tables. Okay, and let's discuss what route tables are. So route tables, VPC. Let's explore some sample diagram for VPCs. Okay, yeah, this seems to be a good one. So here, if we see this diagram, in every VPC, there is an implicit VPC router, which we do not have to create it ourselves. But in every VPC, there will be a implicit VPC router, which basically routes traffic in and out of your VPC based on the route tables that we define. Okay. So route table, what is a route table? So route table is simply a set of rules based on which this VPC router decides how to route the traffic in and out of VPC. Okay, so now we'll see how to create route tables and how to associate route tables to different subnets. And basically route tables are what route tables are. These are some set of rules based on which VPC router decides how to route traffic in and out of VPC. So what does it mean is basically, see, route table would know in route tables, we'll create some entries in that, and we'll say we'll define something like uh, say for example, let's say in our company we have created 2 VPCs. So VPC1 has a CIDR block something like this, 192.168.10.0/24. Other VPC has the network address like this. So in a route table, what we can do is, and how do we peer to VPCs? So how do we connect to VPCs? By default, out of the box, each VPC is isolated and there is no way they can talk to one another by default. If you want to connect them. If you want EC2 instances running in one VPC to be able to connect to the EC2 instances running in another VPC, you have to create something called as peering connection. Okay, so we have to peer the VPCs, and accordingly we have to add entries in the route table. We'll say that in route table we can have one entry something like this, that any anything destined anything destined for this address, any network packet destined for this network address should be sent over the peering connection. One example of a route table entry could be this, that say for example when we are considering this VPC, so for this VPC we can have a route table in which there is an entry something like this, wherein in that route entry there is a route added, and it is something like this, that anything that is destined for this network that should go over the peering connection. The other could be like anything that is destined for internet, should be sent to the internet gateway. So another example is this. So we'll see. Now let's start creating route tables. I think that would make more sense. So we'll go to route tables and we'll say create a route table, and we'll give this route table a name. We'll say public route table, and we'll in which VPC we are creating this route table, QA VPC. The VPC to use for this route table is QA VPC. And
basically we will create route table and allocate that IP that we use to create right?
um, okay, let's see here that as of now we have created one route table and we have named it as public route table. Okay, and what we are going to do is, if you see in this route table, there is just one entry, which is default entry. Whenever you're going to create a route table, there will always be one entry added by default, which is basically this entry is represents the entire VPC, and it says that target is local. So what does it mean is, uh, if we consider this VPC, uh, you know each EC2 instance running inside this VPC can talk to each other, no matter in which subnet they are. So say for example, web host 1, this is in public subnet 1. It can talk to web host 2, which is running in subnet 2, because they are all part of the same VPC. So all can communicate to one another because they are all running in the same VPC. So to make internal routing possible, we don't have to add any explicit route. That route is already added by default for us. So basically this entry that you see here, which came by default, this entry makes possible this internal routing. So any instance running in any subnet within the VPC can talk to any other instance running anywhere within the VPC. So for that kind of routing, we don't have to add any explicit route. That is taken care by default. But if we want to add some explicit routes, that we can add it, and that is what we are going to do now. We'll say edit routes, and we'll say add a route. We'll
So,
say
yeah,
yes. Sorry.
yeah, sorry, Shubham. Yes, Salman here. So, Shubham, we'll be defining the routing table at VPC level and not the AZ level, or like irrespective of the subnet which are hosted on AZ1 or AZ2, any availability zone, they will talk to each other, correct?
Yes. So basically,
Okay.
see, I mean, when we create a VPC, by default, you will also get one main route table. Okay. We'll see to that
Mhm.
now. Just let's complete this route tables, and then we'll
Sure, sure.
see,
Yeah.
and we'll attach So what we have done so far is we have created one custom route table, okay, which we have named public route table. If we go here, we open this and we see the routes, what routes are available in this route table. There is one default route which was added by AWS itself. And what this route does is basically it makes this internal routing possible. So, any instance running on any subnet, irrespective of, I mean,
Correct,
where
correct.
in which availability zone it is in, or irrespective of in which subnet it is in, it can communicate to any other instance within the same VPC. Okay, so I mean, web host 1 can
Got it.
talk to DB instance. It can also talk to web host 2, and vice versa. So any of four entities can talk to one another because they are part of the same VPC, and AWS has already taken care of that, and it has already added one route which basically does
Hmm.
exactly the same, right?
Sure, Shubham. Yeah,
So
got it. Thank you.
yeah, let's try to add one route. We'll say add route, and we'll say anything that we want to send out to the internet. Okay, so this is how we represent internet: 0.0.0.0/0. Anything that we want to send out to the internet, or anything that is destined for internet, that should go to where? Internet gateway. And what is the internet gateway that we have attached to our VPC? It is this internet gateway. And we'll say save changes. So as now we have created one additional route in the route table which we just created. And in that route, what we are saying is anything that we want to send out to the internet should be sent to this internet gateway. It basically takes care of basically providing internet access. Okay. And now what we'll do is we'll associate this route table to the subnets which we want to make public. So each route table would be associated to some subnet. Okay, so we go to subnet association and we'll say edit subnet association. And since we want to make only two subnets public, that means we only want to give internet access to two subnets only. So we will associate this route table to only to the public subnets. If we associate this route table to private subnets as well, then they would no longer be private subnets, because even private subnet would have a way out to the internet.
But how would the private subnets talk to each other in that case?
Sorry, what?
How would the private subnet talk to each other in that case?
No, see, private subnet can talk to one another. Within the VPC, anybody can talk to anyone. So irrespective of whether it's a private subnet or not, see, even a private subnet can talk to instances running in the public subnet
Okay.
because they are all part of the same VPC. If I create another VPC, then this private subnet would not be able to communicate to some other instance which is running in some other VPC.
Okay.
So now we know what route tables are, and how to add custom entries into route table, and how to associate route tables to subnets. So far what we have done is we have created a VPC. We have created 4 subnets. 2 of them we are calling as public subnets. 2 of them we are calling as private subnets. Why are we calling them public and private subnets? Because 2 subnets which we are calling public subnets, those have a way out to the internet. They can connect to basically they can reach out to any machine on the internet. But 2 subnets which we are calling private, they do not have any way out to the internet. They do not have internet connectivity. That is why we are calling them private subnets. But no matter whether those are private subnets or public subnets, each of the subnets can talk to one another because they are all part of the same VPCs. So does it make sense?
So you don't need a route table to talk within each other within the same VPC.
No. Actually, there is also one more thing that I want to tell you is whenever we create a VPC, There is also a main route table, which is created by default.
Oh,
So
okay.
whenever we create a custom table, whenever we create a custom VPC, a main route table also gets created for the same VPC. And any subnet which is not explicitly associated to any route table, that by default is associated with the main route table. So what
Uh,
does it mean? If I go to route tables, and let me uh, I don't know what what this section is and how to uh, drag it. But if you see here, we see three route tables are there. Okay, and this route table that you see, is it a main route table? Yes. This route table that you are seeing, is this a main route table? Yes. This route table which we created ourselves, is this a main route table? No. It's a custom route table that we created ourselves. Okay, so whenever we create a VPC out of the box, by default there is a main route table that gets created automatically, and any subnet which is not explicitly associated with any route table, all those subnets will be associated with main route table. Okay, so what does it mean? The private subnets to which we have not associated the public route table, those two subnets are associated with main route table, right? So
Correct.
got it.
so
Yes.
yes, so this is the main route table, and this route table is part of which VPC? QA VPC.
Correct.
And this is something which we have not created. This is something which AWS has created by default for us. And if we see subnet association, it says the following subnets have not been explicitly associated with any route tables and are therefore associated with the main route table. So
Hmm.
these private subnets
Private
are associated with
communication.
the main route table. And what route we have in this route table? Just the default entry, which basically makes the internal routing possible within the VPC.
Internal.
Hmm.
Right.
Right. So any questions so far?
No, this is quite clear.
This is quite clear, right?
No, Shubham. Yeah,
Shubham,
yeah, yeah.
Yes.
no firewalls, anything currently we have defined, right? That would go forward and define next.
Yes. So far we have not created any firewalls, and so when it comes to firewalls, there are two types of firewalls. One is security groups, and one is network access control list. So this network access control list, or NACLs for short, these NACLs are attached at subnet level, and security groups are attached at EC2 instance level or VM level. So we'll see later on, how to create NACLs and how to associate it with subnets. And there is a difference between, security groups and NACLs. Security groups are stateful firewalls, and NACLs are stateless firewalls. We'll see what these term means and what does it mean when we say stateful or stateless. So since we have done this
True.
much, let's quickly launch one EC2 instance or one virtual machine in our custom VPC that we created,
VPC.
and then we'll wrap up
Yeah.
today's session.
Sure.
Sure, Shubham.
It's not too overwhelming, or it's not like too much I have already told you in this single session.
No, no.
It's fine, right?
Yeah,
Yeah, yeah.
yeah.
You can go ahead with EC2 instance.
Okay, so let's create an EC2 instance now. So we'll simply search here EC2, and what does EC2 are? These are virtual servers in the cloud, or virtual machines in the cloud. So we'll go to EC2, and then we'll go to instances, and we'll say launch instance. So EC2 instances are launched from something called as AMIs. What AMIs are? AMIs are Amazon Machine Images.
It, image.
Okay, so basically for each operating system there will be some AMIs. So most of the AMIs would be provided by AWS itself, but there is something called as AWS Marketplace, where even a lot of software vendors or technology vendors can register as a seller, and they can also create their own AMIs and sell in Amazon Marketplace. So we'll select Amazon Linux AMI, but there are a lot of AMIs available for us. It depends upon what are our application requirements. So say for example, our application is only supported on Red Hat Enterprise Linux or SUSE Linux, then I mean we have to select one of them. Say for example, SAP has a very specific requirement. You can't run them on say for example CentOS or Ubuntu. I mean the only three operating systems which are supported are Red Hat Enterprise Linux, SUSE Linux Enterprise Server, and Oracle Linux. So these are the three supported Linux operating systems. So we can't use Amazon Linux in that case. But I mean, we are not going to deploy something like SAP here. We are simply going to install a web server, and it basically pretty much runs on any operating system. So we are selecting Amazon Linux
So
AMI here because there are a lot of pre-installed tools in it. But of course, we can choose anything we like: Red Hat, SUSE, Ubuntu, or Microsoft Windows.
yeah, Shubham, hello.
Yes, yes.
Yeah, so as you say, like suppose like we are trying to migrate our databases to AWS. So as our database runs on Red Hat Linux, so we will be in that case we'll be creating EC2 instance on Red Hat Linux, say it right? Not on AWS.
Um, yeah, normally, yes, correct. But it depends upon whether you want to, transform it or re-architect it. It depends upon eventually how are you going to migrate it. There is a service called as database migration service, which basically does the same. Or you want to do something like, what is that? Oracle. But I forgot that utility using which you can,
Data pump
export.
utility.
Yeah, data pump utility. So it
Mm.
depends upon how you want to do it. I believe if you export it and then you import it onto an Oracle database, it should not matter what the underlying OS is, right? Is that
Correct.
really
Shubham,
matter?
so in this case, will it allow us to, add any custom machine image? Like, for example, for Oracle Exadata specifically, it uses Oracle Linux.
Yes, actually, you can create your own AMIs as well. The thing
Mhm.
is, here you see my AMIs. So here, if you have created any custom AMIs, that would be available for you to use here.
Okay,
But
got it.
since, yeah, I'm not sure whether Oracle Linux is available, but let's check.
Mhm.
So there are a lot of them available in AWS Marketplace.
Marketplace. Okay.
Yeah. So
So those
let's
one
stick
be the
to,
paid ones, right? Shubham?
sorry, which ones?
Those images would be the paid ones in the marketplace, which are available.
Yes, yes. Mostly
Okay.
those would be chargeable, and they would have mentioned what is the
Chargeable.
hourly
Okay.
rate for that. Yeah.
Got it. Okay.
So pretty much this community-driven Linux operating systems would be free, like CentOS, Ubuntu, Amazon Linux.
All right.
Uh, so of course you have to pay the per hour or per second billing of EC2 instance, but there would be no AMI charge. But when you choose some commercially licensed operating system, there will be an associated EC2 instance per hour billing charge, and there will be an AMI per. I mean, there will be a cost for that AMI also.
Okay, got it.
So for now, let's select Amazon Linux 2 AMI because this is a uh, free AMI to use. So we'll select this one, and then there are a lot of instance types that are available, and we'll use based on our requirement. So T2 micro, we would be mostly playing with this instance type only because this is free tier eligible. We're not going to get charged for running instance T2 micro instance. So it has one virtual CPU and one gigabyte of RAM, and there are a lot of instances available, and there are some insane specifications also. say for example, if you see, uh, so so they have some instances which have close to what 6 terabytes of memory also. So a very big one, and it has
So
448 CPUs.
so Shubham, as
Yeah.
an architect, as an AWS architect, what would be the criteria to select the instance type, basically?
S- See, normally there is something called as instance families. Okay, so say for example, there would be compute intensive, or there will be some. There is the C4 family, so which is compute optimized VMs. There is some M series EC2 instances. Those are memory optimized, and some are burstable. So it depends upon what your application requirements are, and based on that, you would go with the specific family, and within that family also there are several instance types, and you would choose based on, in case you are migrating from on-prem to AWS, then you can have a look at the existing server inventory and what specifications do we have on premise, and whether we have seen any kind of performance bottlenecks or not. If it ran probably, I mean, it was fine, the sizing was done correctly on premise, then maybe we can use the same, I mean, we can pick a instance type which basically closely matches the specifications of the server that we have on premise. Or if we see, for example, some historic CPU utilization, and we see that, we have seen that at times CPU CPU has reached like 99 or 100%, or there was some CPU bottlenecks, or at several times there was a high CPU usage, then maybe it's a good time to, maybe choose a little bigger one, the one that we have on premise. So something like that, and
So,
based on application also. Yes.
is there any formula, something? Because suppose working as a freelancer, and there is a startup company that wants to migrate to AWS. So what would be my suggestion? Just a
See, I
question.
mean, truly speaking, see, every application has some requirements. Say, for example, if you do, and even the sizing is done very differently. Talking about SAP, so SAP applications have something called as, they have their own utility of on how to size it. So, for example, if I search for SAP Quick Sizer, so SAP Quick Sizer is an online utility wherein you can go there, and you can enter a whole lot of inputs into this Quick Sizer tool, and then it will basically, at the end, it will split, I mean, it will give you some certain specifications that, okay, if you want to run this application, you would require these many CPUs or at least this much of RAM. So based on that, you would choose the right instance type. So how to size, uh, I mean, varies from application to application.
Okay, so
And
basically my question would be, like as a DB, my question would be how many databases are running in your system, and I'll calculate the allocated GBs to those database and do some calculation and then decide the machine type, right? And correct?
yeah, so one would be, we can ask them if they have some reference point, as in that, I mean, are they already running that server somewhere else other than AWS? Is it on premise, or be it some other cloud provider also? So
Mhm.
if they already have that, then we can check either their server inventory, or if they don't have it, we can log in at operating system level also. We can see how many CPUs they have, how many memory they have, and then we can also ask them if they have anything, something like, past historic trend of CPU and memory utilization. I know in Linux there is something called as SAR. So SAR is System Activity Report. So that SAR tells you, it logs basically every 10 minutes the CPU utilization and memory utilization. So if you see here, SAR, System Activity Report, so this is available in Unix like operating systems, and if you execute there is a way of executing it. Based on what time frame you have selected, it will tell you that what was the CPU utilization on a specific date or on a specific time interval. So maybe you can select last 1 month and see that what was the CPU utilization. So sometimes, maybe they have not sized it correctly, and we see that the on an average the CPU utilization is hardly 40 or 50%. Then why to over provision in the cloud, right? We see that it the maximum CPU utilization we have seen is hardly 50 or 60. So maybe we can choose a instance type which is a bit smaller in size. So all those things we can consider. Or anyways, if it's like so everything from scratch, there is no reference point. uh, the good part in AWS or any cloud provider is that you can quickly scale up. It hardly takes just a couple of minutes, and you are not stuck to any specific instance type. It's not like you have actually purchased the physical hardware and you can't get it upgraded or
So,
replaced.
so we can't scale down. It's just that we can
Scale
only scale up.
no, both is possible. Scale up and scale down is just a matter of minutes, but
Okay.
but there will be a downtime involved, but the downtime would not be more than minutes. So there is something called as vertical scaling and there is something called as horizontal scaling. So in cloud, not just in AWS, this horizontal scaling is always preferred, and the vertical scaling is not preferred because the vertical scaling, one, it requires a downtime. It involves a downtime even if it is minutes, but it is still downtime. Sometimes it's difficult to get downtime for mission critical production systems. So it is always preferred. If you can scale it horizontally, then it is best. But if you can't do it, but of course you can always arrange a downtime, maybe in off business hours. It will just take minutes and you can quickly scale up or scale down. We'll see that also. It's
Okay.
just a matter of minutes. Okay,
Okay.
so for now
Shubham, what was that name you said? SAP what sizer?
it is called a SAP quick sizer.
Quick sizer. There
Yes.
can be similar to for DB team as well, right? Uh,
Yeah, there could be.
yeah,
Yes.
because you enter some kind of parameters and you get an average of what you can do, right?
Yeah, normally every technology vendor should have some kind of a sizing utility,
Mm,
because these enterprise applications are very difficult to size because it depends
correct.
upon a lot of users, like how many concurrent users will be logging into that application, how large is the data volume. In SAP, it asks you a lot of things like how many sales order per minute would be processed, how many line items per sales order. So they will be asking you a lot of questions like how many users would be working on this application concurrently, how many users would be high activity users, how many users would be low activity users. Say for example, one user could be like CFO or some big guy who only logs into the system just to approve purchase order worth 50 crores or more. So he literally does nothing. So you have to also consider all those scenarios that okay, he's a user but he's a low activity user, and there will be some users which are high activity users, which basically some could be uh, some might belong to accounts payable, some might belong to some other team. Those are high activity users which basically do their day in day out job on that SAP system. So all those factors needs to be considered, and then ultimately that sizing utility would tell you some specification, and then based on that you would go and select the right instance type. Similarly, it should exist for other applications too.
Correct.
Okay.
Okay.
Okay, so we'll select uh, the one which is free, because there's no point in using a very big one. So let's select T2, and we'll select this T2 micro because it's free. It has one CPU, 1 GB of memory. Next, configure instance details. So now we can select where in which network we want to launch this EC2 instance. We don't want to launch this in default VPC, but in our custom VPC, QA VPC. So now it is asking us in which subnet you want to deploy this EC2 instance. So since we will be installing a web server on this EC2 instance and we want to access it from the internet.
Public.
So we'll choose one of them, public subnet 2 or public subnet 1. Any one is fine. So let's select public subnet 1.
Hmm.
Then auto assign public IP. Yes, we want to assign a public IP because then only it will be publicly accessible. I mean, these private IP addresses are not routable on the internet. So if you want to access any machine on the internet, it has to have a public IP address. So that is why we are assigning a public IP address. We are saying enable. And then the rest of the options we can skip for now. We'll get to these options later on. There are some stops. There are some options which are pretty self-explanatory, like protect against accidental termination. So if we enable this on, if somebody would try to terminate this, it will not get terminated. It will say that this machine is, this machine is protected against accidental termination. If you want to delete this, if you want to terminate this, you have to, turn this off so that nobody accidentally deletes it or terminates it, because he would get this pop-up, and then if he after reading that pop-up also, if he explicitly goes and turn off this accidental termination, then it's not accidental termination, it's a deliberate termination, right? So this is a simple thing, and we'll see the rest of the options later on. So we'll say add storage. So by default, every EC2 instance that you are going to launch will have a root volume. So root volume is the volume where your operating system is installed. But in addition to that, if you want additional hard drives, if you want additional, disk, then you can add here. For now, we are not going to add any additional disk. We are just going with the default one, root volume. Root volume is the volume or the disk where our operating system is installed. Depending on our requirements, we can add multiple disk here, and then we can use it. We'll see how to format it and mount it. Add tags. So we can say something like, what is the name? What is the name of this EC2 instance? Maybe it's a web server. Web server 1. We can have a key pair, something like environment, development, and a lot of other key pairs we can attach here. Configure security groups. So here, so security groups are what? These are firewalls. So this is where we define what kind of traffic is allowed inbound and what kind of traffic is allowed outbound. Okay. So we are going to allow HTTP and SSH. So I'm naming this group allow HTTP and SSH. So this is the name of the security group. Let's keep the same as the description also. It's a good idea to restrict SSH to a specific network address or specific IP addresses. It's not good to keep it open for all. So in my case, I will simply say my IP. So only if basically connection is coming from this specific IP address, then only SSH is allowed. Otherwise, it is denied from any other IP address. And HTTP, I will allow for all. I will say anywhere, because a web server or a website should be accessible to all, because that's how we get anybody who is interested, they should be able to access our website. So I'm allowing SSH from my specific IP, and I'm allowing HTTP from anywhere. Then review and launch, and then this is here we can. So by default, all the mostly typically any EC2 instance that you are going to launch from AMIs that are provided by AWS, those AMIs will not have password authentication enabled. You have to use key-based authentication. That is compulsory because of security reasons. Later on, once you once you are inside that virtual machine, then you can optionally enable password authentication if you want. But by default, AWS doesn't give you that option, and they will force you to generate a key pair. So that is why we are generating a key pair now. So we'll give the key pair a name. Uh, let's say this is what, web server 1. This is the name of the key pair, and you have to download it uh, now itself. There is no option to download it later on, so only you have to download it while you are launching it. So I'll download this key pair now. So I have this private key part on my machine, and the public key would be on the server. So they basically handle that stuff. So basically they generate a key pair, they give the private key to us, and they will push the public key of the of this key pair onto the server, and then we can continue. So this is done, and then we'll say launch instance, and then let's see. So currently we see instance state is pending. In 1 or 2 minutes it will go to state running probably, and then we'll try to connect and see uh, how it looks like and whether or not we are able to connect. And we'll try to install a simple Apache web server, and we'll try to access it from the internet. So now we can see instance state is running. If we select this, here we can see specific details about this instance. We can see what is the IPv4 address, public IPv4 address of this EC2 instance. So I will copy this, and then now we'll try to connect to this EC2 instance. One easy way is you can click on this connect button, and then you click on SSH client, and then they have also given us the command. So we'll copy this, and then we'll go to our terminal, and I'll go to the downloads directory where my private key is placed, and then I'll paste the command which is mentioned here. We'll explore the other options of connecting later on, but for now we'll try to connect with a simple SSH client. You can also use PuTTY if you want, but I think in modern Windows 10 operating system this SSH is inbuilt, so you don't have to download PuTTY, but of course you can always download it and use that as well. So now let's try to connect. Yes. Ah, what is
So,
this?
how will it come to know like that private key is in that file? Okay, web server 1.pem. Okay.
Download
It's in,
location.
yeah,
So
that's the
Shubham,
download location.
I think you have two downloaded files. So one is the
Yeah,
recent
underscore
one is 1 on 1.
one bracket
Uh,
one. Yeah.
yeah,
Ah,
one
is it?
bracket one. Yeah.
Yeah,
Okay,
yeah.
let's
So
see.
you need to
So,
either change the name over here or over there.
Mm.
okay, okay. Yes, let's see. So, do we have two here? Um, yes. What is this?
It won't allow Shubham because you already have one of the PEM file named as web
Okay.
server 1.
So let's try to delete that first, and then web server 1.
You just type. Ah, you can
But I
delete the
don't
old one.
see it here.
You
Uh,
can delete the old one. 6 1747.
Maybe you can change the name
server.
of this one underscore new.
Yeah,
Of
correct.
course, yes, let's do that. So this one, right? So let's
Yeah.
rename this to uh, let's let's say EC2 let's
EC2
say
web server.
AWS. Let's say AWS EC2. Okay, so now let's try to CD downloads SSH-I AWS2.pem. Then, and one thing you have to remember is that by default there will be a user called as EC2-user, and this user would differ from AMI to AMI. If you launch a EC2 instance from an Ubuntu AMI, then the user would be Ubuntu. If you are using, say for example, Amazon Linux AMI, or even RHEL, I think the default user is EC2-user. So we'll use this one, EC2-user at the IP address. And what's the IP address? We can check it either from here or anyways from here also it's visible. Is it AWS EC2.pem? What is the problem here?
Is it
Connection
the
timed out.
is it like we have to you give it in double quotes only, like it was showing the example?
It shouldn't be the case. Shouldn't be the case. Let's see. It is saying connection timed
Open,
out.
open. Sorry.
So how can it be? Let's see. That is very odd. Or somehow maybe my public IP might have changed. This is very odd if something like this has happened, because I'm trying to telnet on port 22 and which is not happening. And I remember we allowed from my IP. So let's try to do that again. If I go to security and so this is the security group attached to this, and these are the inbound rules. And let me edit this, edit inbound rules. And let's, if I select this, if I say my IP, see, you can see here it has changed, right?
Yeah.
So maybe this is very odd, but okay. So now we have fixed this. Let's try to let's see if we can do it now. Okay, good. We are able to connect now. So hopefully that thing should work now. Okay, we are inside. Okay, good. So we are inside that EC2 instance that we have launched, and to verify that we have internet connectivity, what can we do? Maybe we can ping google.com. So we are getting a response from google.com, and let's try to install a web server now. I will switch to root user, and then I will say yum install httpd. So yum is what? Yum is a package manager for Linux. So
Yeah.
using yum, you can download packages or whatever softwares you want. So I'm downloading Apache Web Server httpd. I will say yes, and it is getting downloaded and installed. So it has been installed now. Now let's start Apache Web Server. It's quite simple to do it. Service httpd start. So it has been started. Let's check the status. So it is active and running. Now, if you remember, in the security group, we have allowed HTTP and we have kept it open for all. So let's try to connect it from here, and let's try to access it from the web browser. If we go to
So
details,
Shubham, while we
yes.
installed Apache server, can we also see that here in AWS console?
I mean, you would not be able to see it here because they would not have visibility what is happening inside your VM, because that would be a security issue, right? Then how come, I mean, customer would trust AWS because they would know they have access to OS.
Okay.
So
I
like you,
think
how
it
you
is
install,
logical, yeah.
how you installed Apache server, these packages are already available inside those EC2 instances.
See, actually, in Linux, there is something called as repositories. So it depends upon what repositories have been configured in your Linux server, and whether you have access to those repositories. Access in the sense that there is no firewall stopping it from accessing or reaching out to those repositories. So uh, based on that, you can install packages whatever are available on those repositories.
Any way to check that repository?
Yes, there are ways of doing it, but I don't remember it. But maybe I can tell you those specific commands later on,
Mm-hmm.
uh, or maybe you can Google it here also. There's no issue. Uh, check repositories. Uh,
Linux.
Linux. Yum also.
Yum repo
Yum
list.
repo list. Okay, yeah, let's do that. Yum repo list. So I think they have given this, and there would also be a URL of it. So we can see uh, where exactly those repositories are hosted and what packages are there. But typically, this is something that a Linux admin would be doing it. I mean, as an AWS administrator or specifically as a solutions architect, you would not be doing something so low level. Of course, it is good to know, but
Mm.
still. So so
Okay.
far, any doubts that we have done in this session?
Yes,
No.
I have one doubt. The PEM file which you downloaded. So
Uh-huh.
say I just I misplaced that file, or say my system has crashed and they just format it. So how do I get that PEM file again?
Actually, unfortunately, there's no way of getting that again. So, but there are ways of handling it. Uh, there are ways of handling it. Of course, normally, see, you should not be having a single user. So you might have created other users as well, and then you can actually configure other uh, private keys also. But the simple answer, in case if at all you do not have any other user, you just have one EC2 user, and that has a private key which you have misplaced. So there is no way of recovering that private key again from the AWS management console, because they do not keep it for you, because otherwise that would be a security issue. Because if AWS is keeping the private keys, then that means that they can use the private keys to actually access your data or log into your instance. So for security reasons, they do not keep it on themselves. It's your responsibility to keep it safe. But if at all, if you misplace it, so one simple solution would be uh, you create an AMI of this EC2 instance, then you can terminate this or stop this instance, and then again you launch a new EC2 instance, select the AMI that you have created from this EC2 instance, and use that AMI to launch another EC2 instance. And while launching it, you specify or generate a new key pair, and
Okay.
then
But
you can
yeah,
yes.
Shubham, that is if it is a web server or something like that, it is fine. But in case of a database server, if it is a database server, then there will be loss of data also, right? If it is something on the local file system, the data is on local file system.
Yeah, of course, there will be no graceful shutdown, because since you are not able to log into the server itself, you will not be able to do a clean shutdown of the database server. And if at all you do and take an AMI, which involves, of course, there will be a downtime. So there are ways of doing it. One is through Systems Manager also, but for Systems Manager to work, there has to be an SSM agent installed on your server. Using that, if all those things are configured, then it is possible to log in via AWS Management Console also. But of course that that depends upon whether or not you have configured it uh, the way it should be configured for SSM to work. Later on, see, this is one way of accessing the servers that we have seen today, which is basically using normal SSH client, using the private key. Or now that we have private key, if now we change the SSH config file and we enable password authentication and we have that password, we can log in from any SSH client. This is one way of accessing it. There is another way of accessing it, which is browser based from directly from AWS Management Console. On the browser itself, you can log into any Linux instance, but that requires a bit of configuration that relies on one is that there is something called as SSM agent. So you should have SSM agent installed and running, and that server should have access to certain AWS APIs. If all those things are there, then there is something called as systems manager. In systems manager, there is a way to connect to Linux instance even without a key pair. So that is also possible, but that depends whether or not we have configured the instances in that way or not. So normally, of course, you should keep these scenarios in mind whenever you launch an EC2 instance uh, from. I mean, you have launched it, then you should think of these scenarios. What if I misplace this only key I have? Then what would happen in case I misplace it or if I lose it? So either you can create one or more users again, right? Say for example, what is that? SSH keygen hyphen type RSA. I forget what was the thing is.
So Shubham, can we also clone the whole VPC if we want? Like in this case, if we lost the PEM file.
Sorry, I didn't get it.
Can we clone up the whole VPC in this case?
And
If
what
we
is
need to,
what are you expecting out of that? I mean, why do you want to clone a VPC?
so for example, I have to set up a similar in some different AZ zone. Like we set up this in the Asia Pacific zone. So I need to configure it in some other AZ region. So is it possible,
Um,
like if we can do it for some other environment, like QA VPC, we did it here. So in case, yeah, we need to do it for some fraud fix VPC.
Normally, I believe for something like that, as you would use infrastructure as code. So what I mean is there is a service within AWS called as Cloud Formation. In Cloud Formation,
Okay.
you can pretty much define the provisioning of any resource in the form of a template. So in JSON or YAML, you can write it, and then you can keep running it, and then every time you would have the same VPC. So if you can define that
Got it.
VPC creation in a template, then you can run it n number times and you will have the same VPC. You don't have to do n number of clicks. But there is no easy option in cloud in this management console wherein something like select the VPC, right click,
Mhm.
clone. So that kind of option is not there. But you can describe that VPC creation in the form of a
Mhm.
template, cloud formation template, and then you can keep running that cloud formation template to get the same VPC, same set of subnets, same set of route tables and everything.
Got it, Shivam. Thanks a lot.
Okay. And normally in a real world, I think people prefer Terraform instead of CloudFormation because Terraform is also quite easy to learn and moreover it's cloud agnostic. So Terraform is not something specific to AWS. So if you learn Terraform, then those skills are portable. Terraform works for GCP, works for Azure, works
Got
for
it. Got it.
AWS. Yeah.
Mhm.
So does this answer questions or still we have more?
I'm good,
No,
Shivam.
Shubham.
Thank you.
Okay. So we'll try to do such things. Maybe later on when we'll see how to use Systems Manager to log into to Linux instances, or even for Windows, you have this option to get PowerShell console. from the browser itself. So those options also we'll explore, how from the browser itself we can get SSH access to the Linux servers, and uh, what it takes to get access like that. And if at all, if we misplace that this private key, then what options do we have? Of course, that is not a cleanest way of doing it. Say for example, if it's a database server and you can't just reboot it or stop it, then those are of course, but that's the only way. What can we do? And so far, to summarize, these are all things we have covered. We have seen what private IP address ranges are, how to do subnetting. We have seen how to create VPCs, how to create subnets inside that, what route tables are, and how to associate route table to subnets, what main route table is, what the other custom route table that we have created is, and what internet gateway is. And we have discussed some high availability architectures, and then we have discussed how to launch an EC2 instance into our own custom VPC, how to access it, and and all sort of stuffs. We have discussed bit of security groups also.
Right.
So any questions, or shall we wrap it up for today?
No, Shubham.
Okay, good. So maybe try doing this maybe tomorrow. Tomorrow we have an off, right? So
Hmm.
try doing all
Right.
these things.
Yeah.
Try creating custom VPCs and launch an EC2 instance. Then after tomorrow we'll start again.
So Shubham, just a quick question. This is like Monday, Wednesday, and Friday we will be having, right? And again after that, again repeat from Monday, or like how are we going to plan it?
I mean, I'm okay even on weekends also. It depends upon I mean, if you want to do it or not. See, it's not something that is, it has to be done on Monday, Wednesday, and Friday. If at all you have some plans on Friday, if you think we should do it on Thursday, then we can decide, we can discuss if that is possible.
Okay, sure. Yeah,
Okay, sure.
So you guys can discuss and post that in the group. If you don't want to do it on Friday, you think
sure,
Saturday would be good. So that also we can do.
Okay. Yeah, sure.
sure.
Okay.
Yeah.
Okay. Thanks a lot then.
Okay,
Have a
thanks,
nice
Yeah.
Shubham.
evening.
Yeah,
Yeah. Thanks,
Shubham.
Shubham.
Thank you, Shubham. Thanks a lot.
Bye, everyone. Have a nice day.
bye.
Bye. Bye. Good night. Yeah.